Modern crate engines come pre-certified and tuned before even hitting the market. Recently, Mary Barra, CEO of General Motors, dropped a bombshell that sent shockwaves through the automotive world. In an unexpected move, she unveiled a groundbreaking internal combustion engine technology that, as she suggests, could shake up the electric vehicle industry entirely. While the global trend has been accelerating toward electrification, this bold strategy from one of the largest car makers challenges the widely accepted belief that the future is purely electric. Barra's announcement signals a renewed focus on internal combustion engines and raises big questions about where the auto industry is really headed next. For the past decade, the automotive industry has been on a transformative journey toward electrification. Governments worldwide have been imposing stricter emission regulations, while car manufacturers have raced to develop electric vehicles that meet the growing demand for environmentally friendly transportation. Companies like Tesla, with its range of highly successful EVs, have largely dominated the conversation, pushing the narrative that the future of mobility is electric. However, GM's latest move under Barra's leadership could shift the landscape in unforeseen ways. The new engine technology is said to combine the best of both worlds, the power and reliability of traditional internal combustion engines with unprecedented levels of fuel efficiency and reduced emissions. According to Barra, this new engine is designed to outperform even the most advanced electric vehicles in terms of range, cost, and overall environmental impact. While the specifics of the technology remain under wraps, GM has hinted that it involves advanced materials, cutting-edge combustion techniques, and innovative engineering that dramatically reduces energy loss and enhances fuel combustion efficiency. One of the key advantages of this new engine is its ability to match and even exceed the range of electric vehicles without the need for frequent recharging. Range anxiety has been one of the main concerns for potential EV buyers, with many consumers hesitant to switch due to limitations in how far they can travel on a single charge. Despite advancements in battery technology, charging infrastructure remains inconsistent, particularly in rural and less developed areas. GM's new engine, on the other hand, leverages the widespread availability of gasoline and other fuels, providing a level of convenience that EVs are still striving to achieve. Moreover, the new technology promises a significant reduction in carbon emissions, which has been one of the main drivers behind the push for EVs. Traditional internal combustion engines have long been criticized for their environmental impact, particularly greenhouse gas emissions. However, GM claims this new engine will incorporate advanced catalytic converters, exhaust gas recirculation systems, and other emission-reducing technologies that could rival the low emissions of electric vehicles, especially when considering the entire life cycle of the vehicle, including manufacturing and disposal. Barra's announcement has not only shaken the foundations of the EV industry, but also sparked intense debate within the broader automotive community. Many industry experts are questioning whether this technology could truly reverse the trend toward electrification, or whether it is simply a temporary innovation that will eventually give way to the inevitable rise of EVs. The timing of the announcement is particularly intriguing, given that GM itself has been heavily investing in EVs, with plans to phase out gasoline-powered cars entirely by 2035. This new engine seems to represent either a strategic pivot or at least a hedge against the uncertainty surrounding an all-electric future. In the broader automotive landscape, GM's new engine could pose a serious challenge to other car makers that have bet heavily on EVs. Companies like Ford, Volkswagen, and BMW have all committed substantial resources to electrification, with models like Ford's F-150 Lightning, Volkswagen's ID series, and BMW's i4 leading the charge. If GM's new engine delivers on its promises, it could force these companies to reassess their strategies and possibly slow down or adjust their electrification plans. Other EV manufacturers, including Rivian, Lucid Motors, and even legacy automakers like Ford and Volkswagen, will likely double down on battery innovation, charging infrastructure, and sustainable manufacturing to stay competitive. They may also invest in better recycling processes for EV batteries and renewable energy integration in production. If GM's engine technology gains traction, it could disrupt the traditional automotive supply chain as well. Suppliers that produce engine components, transmissions, and other ICE-specific parts could see a resurgence in demand Regulatory pressures present another challenge. Many governments have already set strict timelines for phasing out combustion engines while investing heavily in EV incentives and charging infrastructure. For GM's new engine to truly disrupt the market, it would need to not only meet but exceed global emissions standards enough to convince policymakers to reconsider long-term electrification strategies. That's no small task, given the political momentum behind EV adoption. In conclusion, GM's announcement of a revolutionary internal combustion engine is a bold and unexpected move that reignites the debate about the future of the automotive industry and the path to true sustainability. Consumer perception will ultimately play a crucial role in the success of GM's engine. Over the past decade, consumer attitudes have shifted toward EVs, driven by environmental concerns, rising fuel costs, and the appeal of cutting-edge technology. Many now view EVs as modern and sustainable, while ICE vehicles are increasingly seen as outdated and harmful. To succeed, GM must position its new engine not as a continuation of old technology, but as a revolutionary step forward that addresses traditional shortcomings. This will require a strong marketing campaign highlighting efficiency, lower emissions, and practical advantages such as longer range and faster refueling. Just as importantly, GM must provide transparency through third-party validation of its claims on emissions, efficiency, and environmental impact. Pricing will also be a critical factor. While GM suggests the new engine will be more cost-effective than EVs, the advanced materials and technology involved could push purchase prices higher than conventional ICE vehicles. GM must balance development costs with accessibility if it wants widespread adoption. Other EV manufacturers, including Rivian, Lucid Motors, and even legacy automakers like Ford and Volkswagen, will likely double down on battery innovation, charging infrastructure, and sustainable manufacturing to stay competitive. They may also invest in better recycling processes for EV batteries and renewable energy integration in production. If GM's engine technology gains traction, it could disrupt the traditional automotive supply chain as well. Suppliers that produce engine components, transmissions, and other ICE-specific parts could see a resurgence in demand, giving them room to invest in cleaner, more efficient technologies. At the same time, uncertainty over the industry's direction may push suppliers to hedge their bets, some focusing on both ICE and EV parts, while others risk everything on one path. This could trigger further consolidation, with larger adaptable companies absorbing smaller specialized firms.